Welcome, everybody. Thanks for coming to attend this show. I am Guy Podjarny, or Guypo. I'm from Snyk, and I'm here today to do some live hacking with you of some Spring Functions and maybe learn a security lesson or two while we're at it. Just a little bit of context about me. I'm the CEO and co-founder of Snyk, which is a company that helps you use open source code and stay secure. And I basically have this pretty long history in the world of security, coming from building the first web application security products, first web firewall, web security scanner, earlier in the Israeli army as well. And then I went into the world of performance, where I really dug a lot into this ops world that got a lot of my passion around making websites fast, and then subsequently kind of modern infrastructure, very much the case. And I do a fair bit of this as well. And you're catching me on a good day today. Just earlier this morning, we've announced in our startup, we raised a Series B, large Series B. So thank you, apologies if that is, that was as shameless as they get, really. So, I'm buying the beer, Here, it's on video now, it's captured. So into the meat of it. What we're going to do today is we're going to do a quick intro into serverless and Spring Functions just to make sure everybody's on the same page. Figured it's important. And then we're going to show a demo serverless application. We're going to hack it. We're just going to do a few exploits on it, and we'll talk about what happens in the process. We'll explain the security flaws and talk about how we can learn from them so we can write more secure Spring Functions or sort of serverless environments for it. So first, let me do the most sort of overly simplified review of the journey from monolith to serverless. So at a high level, and I'm talking all of it within the context of the cloud, when you talk about monoliths in the cloud, we're talking about VMs for the most part. And these VMs have their operating system on top of that. There's an application. Applications are generally broad capabilities, a lot of different functions and just sort of power inside of them, and they run it. But it's running on the cloud, which gives you still that ability to work with VMs, to sort of rent hardware, and gives you pretty good elasticity to just sort of launch these machines up and take them down. That's why we moved to the cloud in the first place. The move to containers is this move that basically moves a lot of this responsibility. Not sure if I'm doing something wrong with the mic here. That moves a chunk of this functionality, this responsibility, into the cloud platform once more and uses these containers. Containers are a little bit more nimble. They're running on a certain VM. And once again, they own the operating system and a chunk of functionality of it. Hopefully, the more micro your microservices, the more refined that functionality is within it. But because we move into this environment, it gives us even better hardware utilization because a single VM would run multiple of these containers and maximize their use. It gives you OS flexibility. So if one component needs to be running on Linux and one on Windows and one on Alpine, then you can do so more easily. And it's more portable because you can take these containers, you can run them in various cases. Maybe most importantly, you can scale now on 2 dimensions, on the containers within the VM as well as across the VMs, so you have better elasticity and better scalability. And then serverless is kind of a continuation, in my mind at least, of this journey. But in serverless, a lot of that functionality comes down. So if with the containers, with the move from the monolith to the containers, we've abstracted the components of this system and we move them into the cloud platform, this whole management of the host VM and the operating system has moved into the cloud. So you have no hardware management, you have no OS management, you don't really touch any of those components, and that gives you sort of the best cloud portability to the extent that the third-party services surrounding you, the database and the likes, are things that your environment gives you, and maximum elasticity. In fact, you don't even need to think about elasticity because it just happens. It just sort of runs as part of the platform. You might be operating the platform, that's a different story, but as a developer at least, you have those. And really what you're deploying are these functions, and they're just kind of there in the ether. And they're connected through configuration. They're connected through sort of flows that work within them and event triggers. So this is a very sort of simplistic view. And as more and more functionality goes into the cloud platform, more and more of the security responsibilities and security aspects of it move into those components, or move along to the cloud platform as well. So the platform operates and owns a lot of that security, while a developer is able to not worry about them. And then PaaS is somewhere in the middle. It's not well defined. So where exactly in that trajectory it sits is a little bit hard to say. When you talk about serverless, serverless have, and again, this is serverless is one of the more debated terms about what's captured under that mantle. So I will kind of choose an interpretation here. And I'll say it's made up of these 3 elements you'll be using if you're deploying things serverless. The first is a function as a service platform, so something that is actually able to run your functions. Lambda is kind of the giant in the space. Knative is the kind of the coolest new kid on the block, and it allows you to do this compute, configurations, the permission management about who can invoke them, et cetera, as well as the eventing system, which for many is actually almost the most important aspect of programming. And then you have a deployment system. You have some way to deploy those functions, to configure them, to configure the API gateway that might sit in front of them, or the users that might be invoking them. So serverless framework is the one that's more well known. You know, the simple application model sits in this world. It's not as complete. Maybe Riff. It's hard for me a little bit to really understand where Riff sits right now in this world of Knative. But maybe that's a component. And then last but not least is the programming model. So now you have all these entire systems, but you're a developer, you're writing a function, you know, sort of you're writing some piece of code, and you're used to writing this and compiling this and debugging this in the context of a full application. Suddenly, you're told, no, you just deploy that function. So you need some surrounding, you need some platform to support you. And that's really where Spring Functions comes in. You know, it's not a replacement to Lambda, it's not a replacement to Riff, it's that programming model. And again, somebody will butcher me for this sort of oversimplification here, but I'll just sort of say that Spring Functions really can turn just the bean into this standalone Cloud function. So you just write your code, and it just becomes a thing. The Spring Functions turns it into something that is deployable. So it reduces the overhead and allows you to continue using this sort of Spring Boot style templates and starter kits and the likes. So, you know, it has that opinionated flow, and you can, of course, you can break out of that. It's worth noting that while your function is light, the thing you will deploy to Lambda is not. You know, if you tried deploying Spring Function and you tried deploying, let's say, like a node function, you will notice a very significant difference. But the amount of code you've written is not quite as dramatically. It's just really the surrounding, the platform that you ship with it. So this is just a very brief intro into the content, but this talk is really focusing on serverless security, and it just uses Spring Cloud Functions as this environment. Cloud Functions on their own right don't really have a ton of security conversation around them. It's really the serverless model that they're deployed in that is worthy of conversation. So let's get going. Let's get to our app. So first of all, like, you know, the first component really we'll talk about is relates to where is the code, you know, like what is this application? I just mentioned that we're pulling in those components. So let's do a little riddle. So this is an example of you know, our demo application, which we'll show in a sec. It has a little create. You can see on the top left there, my marker kind of disappeared, but you can see on the left, it has this create to do function, delete to do functions, get to do function. It has a handful of these to do applications. We're going to use a very simplistic to do app, and for the sake of time, we're not going to play with it overly much. We're going to jump straight into hacking it. But it has a bunch of those functions, and because it's Spring Function, most of these functions are really tiny. They look like this function over here, like create to do, apply, super small, that's your entire code, and that's awesome. It means I can write this entire to do application in 222 lines of code, which is not a lot. You know, it's not allowed to build a functioning to do application that is able to kind of edit those and provide an interface. To achieve this wonder, our little application does use 5 different libraries. And they in turn use some other libraries. So those libraries add up to about 54 different components, 54 dependencies. Not terrible, not the smallest, but not the largest. How many lines of code in the total package? Guesses? Sorry? 1,000, what was the appearance? Other guesses? More than 1,000, 1,000,000. Other? 50K. So like the million wasn't terribly off. 460,000 lines of code, 500,000, you know, lines of code in the system. And that's not a bad thing. This is a good thing. It means you could build on the shoulders of giant, right? You could get 500,000 lines of code's value by just writing 222. But it does mean that within that lie some security concerns. You know, like if you have security problems, they're far more likely to lie in the 460,000 than they are in the 222. So that kind of gets us to the first concern we'll talk about, which is vulnerable libraries. So let me introduce our application here a sec. So we're not going to get through too much of it, but as I said, it has a bunch of these to-do functions, create to do, delete to do, just sort of a set of these functions that I've deployed for the sake of time to not upload 100 megabytes here live on the on this application. And it uses serverless YAML file, and the serverless YAML file is this definition, it's the scope that will deploy the application, and it's used by the serverless framework to deploy it. So it has some permissions and setups at the top. We'll get to those a little bit later. And then it has functions like this, create to do, which define the artifacts you're going to use, and defines an HTTP gateway path to them. So just have some curl application. Amongst these functions, we have our import to-dos. And import is able to import to-do items, as the name implies. And a whole bunch of these libraries. Actually, you know what, I'll hold off on the import bit. So we said it's going to use these libraries. I'm going to use Snyk here to just inspect a little bit these libraries to see what do we know about them. So what I'll do is I'll connect to Lambda over here. And this is, you can kind of use your sort of dependency checker of choice for this. You know, we specifically have a connector to Lambda. And not very good Wi-Fi here. Oh, here we go. So it will connect to Lambda. It would ask which components, like which functions do you want to test? And we'll say, well, let's pick on this import one that I showed before. It just has I have some insider knowledge about things that we might find. And we'll add that to Snyk. And what Snyk would do now is it would go off and it would unpack this function, download the zip file, expand it out, and see which libraries are in there. And if we come back here and we just kind of shrink it to just show us Lambda, it would find a bunch. So what it would find is, first of all, it kind of would map out the tree of dependencies over here. It actually found a whole bunch more dependencies, 138, not just the ones that I've mentioned before. That's because a lot of the platforms, some of these libraries actually come as part of the wrappers when we deploy it. And it found that indeed some of those components have vulnerabilities. So this is sort of the first risk we're going to talk about. And these vulnerable libraries have kind of been popularized by the Equifax hack, you know, showing how this vulnerable struts library allowed attackers to break into Equifax. But we're going to pick on a different one. You know, we have Spring Break over here. It's kind of the recent big one. But really, we're going to pick on this one here, Jackson. Who here is familiar with Jackson? Yeah, pretty much everybody. You know, it's kind of the standard way that you would sort of marshal objects, sort of serialize them in the world of Spring. And our import to-dos function uses those libraries. So we're going to have some fun with it. We're going to send it. So the full function, and you know, we're taking some shortcuts here because of just for the sake of time. But the full XML function, you know, if you were to sort of serialize it for the to-do items, is fairly elaborate. But it has this vulnerability, and we know it has remote command execution. Having done some research on the web, as in a quick Google, will get you to a sample exploit that you can do. And basically what will happen is if you've fed it this type of string, and you had it sort of parse it out, it'll identify the XML, and it loses some security controller on it, which allows it to deserialize a process builder and provide these actions into it. So what we're going to do is we're going to run a little exploit here that runs the bash command, and it does a -c to run another command, curl to our etc passwd, and because we need, you know, we're sort of professional attackers here, we need somewhere to send this data to. It's not just going to be sent back to us, so we'll send it to our little URL. So we're going to run this, and I will say, you know, if you've experienced live coding and how that's not always reliable, live hacking, same thing, just. All right, okay, so we have our little server at the bottom, and look at that. We found our etc passwd. So it's interesting, this sort of takes us down a bit of a rabbit hole of, you know, why are there so many of these user logins and all that? This Lambda is supposed to only be reused for me. Anyways, it definitely got a whole bunch of questions asked from me. But it's a starting point. So this is kind of example number one. We're in, you know, we have a little hack on it. Let's get back to our slides a little bit and chat about what we've just seen, and then we'll get back and we'll use that exploit to do some more damage. So I already talked about exploits. So serverless, in this context, you know, these types of vulnerable libraries are not something that is unique to serverless. It's something that you need to address in every environment. But specifically, serverless does secure OS dependencies. And a common misconception is to think that you don't need to worry about dependencies as a whole if you're using a serverless platform. That is not correct. It addresses the operating system dependencies. You don't need to patch your servers because you're not managing them. But you do need to patch your application. So concern number one, beware vulnerable libraries. Just to sort of ease out of Okay. Oh, I guess it is now. So a common misconception when I show this is to think that Snyk is only for serverless. So just as a side point, Snyk is not only for serverless. You can connect it to Git repositories and the like as well. So this was number one. Concern number one, beware vulnerable libraries. Second thing I want to talk to you about is granularity. And to do that, we're going to run another hack, just a small one. So what we're going to do is, initially I was running this command. And what this command would do is it would go off and it would do a find dot. And it would get us all the files, and it would send them, just like we did before, to our servers. And it'll do some discovery. This is what an attacker would do. Unfortunately, I don't have like a really capable server off to the side, and there are a lot of files deployed with this system. So it messed up my buffering a little bit. So we're going to skip this one, and we're going to jump straight to the meat of it, which is spell find to do. So we're just going to find a subset of files, which is I'm going to find anything that has to do in the name, and I'm going to send them to my server and see what we find. So let me run that command. Here we go. So I just pre-prepared these hacks, so they're actually on a public URL, spell find to do files, and we're going to run this, and we're going to hope for the best. And we're not going to get the best. Let's try to run this again. Here we go. My hack is still not entirely reliable. So what have we found here? So we found that remember, we're exploiting the import function. And when we look at the files here, we see create to do, delete to do, get to do. We see all these other functions code, and they've been deployed with it. Any sense why? So it's because we've done what pretty much everybody does, which is we've defined all of these functions in this one repository and have one serverless YAML file, and we run one deploy command, and it deploys a whole bunch of these functions. So it ends up reusing the same jar, the same compile output, because it's easy. And in the process, what I've just done is I've exposed the attacker, or I exposed more of my application to the attacker than I should have. That import function is a very specific function, and yet now I have a lot more data at my fingertips. Well, first, when you talk about, so the first thing we talk about is sort of access to data. So I can go off and I can, as an attacker, and for the sake of time I won't do it, I can start decompiling and understanding code of far more than the import function. The second effect that this has had is this. So as a part of this serverless XML file, or YAML file, sorry, I've defined permissions. And because all of my functions are in one application, these permissions are now the superset of permissions that all of my functions require. So it also means that from my function now, I can invoke other functions because apparently one of my functions needed that capability. I can access the database, which maybe this function didn't need to. So I have a granular, sort of a much more permission than I need. You really want to focus on providing granular permissions. Permissions are this thing that they basically naturally expand and expand and expand until somebody adds an asterisk. That's just sort of the natural evolution of permissions, right? And they never contract. Once somebody gave you a bit of permission, nobody takes it away because you don't know what will break. So it's a very kind of concerning component, sort of a very concerning paradigm when we do this. So this is what we've done. We've sort of deployed all of these functions together, and we've given them these permissions. And my kind of advice is to deploy granular functions permissions. A slightly visual way to do this is to think that this is easier. Remember that it's sort of easier to define all these functions, but this is safer. You want to think about the policy for every one of them. And the good news is that every kind of serverless environment, every function is a service environment, and their deployment models give you a way to do it. Functions actually give you an opportunity to define very fine-grained, very accurate permissions. But you have to use it. You have to not kind of get attracted or sort of fall for the ease of just putting them all into one file. I'll say kind of as a bit of a meta point, which is almost all of the security pitfalls that I see in the world of serverless comes from the fact that serverless is so easy, we forget to do some of the things that are good. It's just so easy, we just go down the easy route, and we lose sight or sort of skip over some important components. So within this function, and I didn't run this deployment, as I said, just for the sake of upload time, I'd like to draw your attention to these to-dos admin and backup to-dos functions. We didn't really talk about them. They actually show up at the bottom of my file here. The to-dos admin is just a bit of an admin API function, and the backup to-do, as its name implies, is a backup function. And what you'd note is that the backup function doesn't have that section that says HTTP. In other words, the backup function which is a sensitive function, because not everybody should be able to invoke a backup action, is not exposed to the world. It's not behind an API gateway. You need to have permissions to run it. And presumably, you've set up your IAM roles correctly. The to-dos admin API calls it when it's relevant. What's the problem here? What's the issue? Any thoughts?
You basically leak the privilege through the to-dos admin over to the back.
So you do leak the privilege. I think more than that, you rely on that enforcement in those components. So it means that right now, we, for instance, have remote command execution. So we're now in the trusted network. You've now given the network, you've given sort of this environment far greater permissions than you intended to. And if I run, and I'll admit that I had an exploit on it and didn't get it working in time to actually sort of invoke this function, through my command line execution, I'm now in that environment. And as we talked about before, I have all the permissions that those other functions have. So I can invoke the same action as the to-dos admin and just invoke that backup to-do. This is often referred to as the fortress security model. Once you sort of got over the walls, you're inside, and there's nothing stopping you. I like to think of it as the M&M security model, sort of a hard shell and sort of soft and gooey in the inside. Once you're inside, you can do whatever you want. So what I would encourage you on those components, and I don't have a hack for this right now, is don't rely on function ordering. So again, this is easy, and this is sort of the natural way you think about things. We deployed a bunch of these functions, we have a perimeter around them, and people cannot go around our perimeter. In this case, the API gateway, kind of our API access was our perimeter. But really, you need to think about them this way. The advantage, the strength of serverless is that it gives us these building blocks, these functions, that we can move around and we can use in different orders, right? Either somebody else on the team or future you in a year's time will go in and will say, well, I can use this backup to-dos function in a different spot because it's so tried and true, it's been running for 2 years, and you just move it in a place that is not hidden behind that, that admin API, and lo and behold, you've exposed a security weakness. So remember, do not rely on function ordering. The next bit I want to talk about, I've got about 8 minutes left, is immutability. So immutability is like one of the big misconceptions about serverless. And to do that, let's get back to our little application here. So as when we ran the previous hacks, actually, I guess we didn't actually run this one. When we ran the previous hacks, what we did was we ran a command, and then we stored it into our TMP file. Right? We did it over here, and the find does it as well. What we're going to do next is we're going to run a different hack, which once again would run a command into a TMP file. And basically what we're going to look for, what are the files in my TMP file, or in TMP folder. And we'll run that over, so let's see. And what would we expect to find? Any thoughts? What would we expect to find? I'll grant you that's a little bit more, need to know what I'm aiming for. Run again. So when we run this, what we find is we see these find to-do files and this list TMP files. So this may or may not seem intuitive for you. When you run a server and you created a file in the TMP file and you're going to list those files afterwards, clearly that file is going to be there, right? Unless that system has rebooted. In the world of serverless, we think about these components, these functions as immutable. We send a command, the server spawns, or sort of the Lambda system or whatever, pivotal function service, spins up a container, runs a command, shuts itself down. But that is not the case. The reality is that all platforms, all functions, keep these containers warm. So you cannot rely on the server running for a long time, but you likewise cannot rely on the server dying or sort of getting reinitialized on every single request. So this is kind of this is an important sort of a fine point, but a very important one. What oftentimes I see, just sort of talking to organizations that build serverless components or thinking about those apps, is you see these small mistakes that just think that they can no longer have, or think about their attack model such that if one function was compromised, it's only really that user and that function that are at risk. But the reality is that if I have that remote command execution and I run a little TCP listener, for instance, I will catch traffic from other users that are flowing through. If I manage to change files on the system, I can modify the behavior for future users. Now, I will give credit to the people running these platforms, and specifically most of my experience here is on Lambda. They're pretty good at their job. So they would do things like running the code in a read-only volume. so that you wouldn't be able to manipulate that too much. Like, they're good at it. The pros are running the platform. Your role is not to rely on the fact that the same server, or that every function would spin up a new server. So this is number 4. And the last example I want to show you, or the last issue I want to show you, is, I'm just going to do this over here. The last function I want to talk about is this one. And the reason I want to talk to you about it is because I don't know how it got there. It's so easy to deploy a function. I was playing around, and I just probably accidentally deployed this function. I wanted to see if it works, and it deployed. And you know what? Now it's deployed. It's not costing me anything. You know, it's just running there. Nobody's invoking it, so there's no dollars being spent. It was super easy to spin it up. You know, why not? You know, why wouldn't I deploy? Serverless basically spins over, sort of, you know, flips over the answer about whether something is worth deploying, saying, well, why not deploy it? You know, that becomes the default motion. And there's a lot of, if you listen around and you look at podcasts or you listen to people talking about serverless, people talk about moving their cron jobs to be serverless. That's kind of the new cron. Or just sort of really deploying all sorts of iterations on it. And then at the end of that, what you end up with is you end up with these functions that have a certain set of permissions that, as we said before, never really contract. And as it turns out, this component actually has the same vulnerability that we've just exploited. So it's a risk. It's a risky component for us. And we have to remember that you have to worry about all the functions. This is maybe the one thing that keeps me up at night kind of the most around the concept of serverless security. Today, we talk about how it's hard to wrangle servers, right? We deploy a server. Managing a server is not that hard. Managing 10,000 servers, that's kind of tricky. You know, you need work, you need effort to do that in a continuous fashion. Similarly, you know, managing a function is easier than managing a server, but managing 100,000 functions is not going to be an easy feat. And you have to think about those ahead of time. You have to think about the permissions you deploy to minimize them. You have to think about your naming conventions to be able to understand, you know, which spaces or which, you know, what are the names. How do you know whether a function is a production function, whether somebody is relying on that? And there's nothing magical about the platforms that just does that for you. This is about your discipline. If you move to use these Spring functions, is creating some norms, creating some discipline within your environment about where do you deploy to, how do you deploy, and think about how would you decommission a function? How do you know that you need to decommission it? Because it's not going to be sort of hardware costs or dollars that drive you to do it in the serverless world. So to summarize, we talked about 5 concerns. We talked about that relate to serverless and Spring functions. 1, beware vulnerable libraries. This is really the new unpatched servers. It's not that new. It exists on regular servers as well. But in the world of serverless, unpatched servers are not much of a concern. Unpatched apps and those dependencies are. You want to deploy granular functions and permissions. The platforms give you all the flexibility you want. Don't rely on function ordering. Think of every function as its own perimeter. Don't rely on immutability. You know, just still think defensively over there, and you have to worry about all the functions. You know, think ahead about how do you manage those components. I will say that this talk was more about sort of the interactive, you know, run a few functions, run a few hacks, sort of see this live and run on Cloud Functions. I do have a different talk that I give about serverless. It's a bit more meta, a bit talking about just sort of how does the serverless security model change. So if you'd like, I'll share these slides shortly after this, and there's a video around kind of a QCon talk, or sort of a serverless con talk that I gave around kind of, again, that kind of more meta model. It's more than 30 minutes. So leaving it with a good note, serverless is a new thing, and it's being defined now. And while we've made various security mistakes in the past, we have the opportunity to build it and build security into this flow. So let's do that. Thank you.